Hey, sixth grade math. Good to see you guys today. This should be Wednesday's class. Today we're gonna. This topic's actually really cool. It's what we call it like creative problem solving type things. But it's really neat. It's called composite figures. Okay. So if you don't have the printer, okay, and you don't want to print this out, or you don't want to print this out, you can either just listen or take some abbreviated notes. You don't have to take all of these notes. If you have the printout, please fill in the blanks, okay? And for those of you guys who don't have the printout, I'm going to kind of simplify the notes so you know what's important today and how to do this. All right, so let's get to it. This stuff's pretty fun. A composite figure is made up of two or more shapes. All right, so think of the word compose. If you compose something, you create it or you make it. So a composite figure, or a figure that's composed, would be made out of two different shapes, okay? For instance, if you guys look at the stop sign, we have an octagon and also a rectangle down here. If you look at this lamp, well, up here you have a trapezoid, and then in the middle you have a rectangle. We're going to ignore that little the pulley thing that you turn the light on with. And then down here you have another trapezoid. Okay, over here, this door, you have a rectangle, but then you have to subtract out the windows because all these windows are rectangles. So if you want to find the area of the door, you have to find the area of the whole thing and then subtract out the windows. Okay, and that's what we're going to be doing today. We can find let me just get my notes here, make sure I'm giving you the right words. We can find the area of a composite figure by adding or subtracting the area of each shape. Okay, now if you don't have your notes and you want to write all this down, you're obviously more than welcome to. But I think I can present this to you in a way where you won't have to write down those notes. Okay, so composite figures are made up of different shapes. Now, the most important thing is we remember these formulas from the other day. Obviously, you won't have to remember them this year because you can go back on your notes for quizzes and tests. But just to give you a reminder, to find the area of a triangle, that's base times height over 2. Okay. The area of a rectangle or a parallelogram is area equals BH. And then the area of a trapezoid is 1/2 B1 plus B2 times height. Okay. So let's look at this first problem here. In fact, I think I'll come back, have you guys do the first problem. Let's look at the second problem because it looks maybe a little trickier. So basically what they want you to see these shapes as is they want you to see them as a composite figure, a figure composed of different shapes. Okay, so like this one over here, I'm going to call this number 2. This shape here is composed, if you drew a line here, this shape, this big house-looking shape, kind of like this one too, is composed of a rectangle down here and then a triangle up here. Okay, I'm looking at this as like one big triangle right here. You could also say it's two little triangles, but let's call it one big triangle up here and then one rectangle down here. So if I have a highlighter, I'm just going to show you guys what I'm talking about. This is a composite figure because it's composed of both a rectangle and also a triangle. Okay, two shapes make one. Okay, so the shape number 1, since it's on the top, let's call triangle shape 1. And shape 2 would be your rectangle. You don't have to make this whole chart if you don't have the printout. You can just write these words and do your work underneath them. Okay, so the formula for the area, it wants to know to find the area of each shape is the directions. They want you to decompose the figure. So decomposing them means to put them into the different shapes, okay, or take them apart. So this one big shape I'm taking apart into a triangle and a rectangle. Okay, so the formula for the area of a triangle is B times H over 2. Okay, that's something we learned last week or earlier. I think it was last week. or it might have been yesterday, earlier this week, Monday. All right, and the formula for a rectangle is area equals BH. So what we're going to do is we're going to plug in our values for the formula of a triangle. The base would be this one, which is 15, because if this is 15, then this one has to be 15. So it would be 15 times our height. In this case, our height of our triangle is 5. And that's all divided by 2 based on the formula, okay? So 15 times 5, well, I know 10 times 5 is 50, and 5 times 5 is 25. So that's going to be 75 over 2, which is going to be 37.5. And that's going to be in meters squared, because area is always square feet or meters squared, okay? Because if you look at the formula up here, this is feet, or I'm sorry, in this case it's meters, so that's meters times meters. And when you do meters times meters, that's meters squared, okay? The area of the rectangle, the base and the height, well, the base of the rectangle is 15, and the height of the rectangle is 9. So that's going to be 15 times 9. I know that I look at this as like 10. Okay, so 10 times 9 is 90. And then 5 times 9 is 45. So I know that my area is going to be 135 meters squared. Okay. And then to find the total area of that total composite shape would be you'd have to add up the area of the triangle plus the area of the rectangle. And some of you guys struggled with this a little bit on your last test. So when you add up something that has 37.5 and then you add up something that's 135, remember the 135 means like 135.0. Okay? So when you add that up, it's going to be 172.5 meters squared. And that's your answer. Okay? Why don't you guys go back and do this one? Same method, different numbers, okay? Look at it as composite shapes. How can you break that into 2 shapes and do it very similar to how we did the second one? Okay, so you guys go ahead and try that one. Okay, now pause the video if you need to, and we're going to go ahead to the back. Okay, so sometimes a composite figure, and if you did that one correct, let's just look here. If you did that last one correct, you should have got 90 feet squared. 90. All right. On the back, a composite figure also includes what we call overlapping shapes. So in this situation, we have a rectangle, which is overlapping a parallelogram. Okay. And they want to know, describe the process for finding the area of the shaded region. Okay, so to find the area of the shaded region, you have to find the area of the bigger rectangle. And then we're going to have to subtract the area of the parallelogram inside. So if you were to find the area of like this whole thing, like all of this, just a rectangle, and then you were going to subtract out this piece, right? So you subtract this area out. Now what you have is you have the area of all of that shaded region. All right, so that's pretty cool. I always enjoy doing things like this myself. So let's go ahead. Let's take a look at number 1. Find the area of the shaded region. Okay, so to find the area of the shaded region, we're going to have to find the area of the whole thing, right? The whole thing, which in this case is what we call a trapezoid. So the area of the trapezoid. All right. And we know that the area of a trapezoid equals, if we look at the front there, it's 1/2 b subset 1 plus b subset 2, which I call base 1 and base 2, times the height. And now you don't have to memorize that formula, but if I give it to you, which I did, can you plug in the right numbers? Okay. So the area of the whole thing, the whole trapezoid, is 1/2. The base 1 would be 15, and the base 2 would be 10, or vice versa. We'll call this maybe base 1 and this one base 2. So I'm going to say 10 plus 15 times, and then the height of the trapezoid is this number here, from where it forms a right angle with a base and goes up. That's the height. So it's 8 inches. Okay, so our next step, if we follow PEMDAS or the order of operations, we're going to add the 10 plus the 15 first, because that's in parentheses. Okay. And then I know a little trick here based on if this is 0.5 or 1/2. So if I just look at that as 0.5 for a second and I multiply and then multiply, there's a property called the commutative property of multiplication, where you can change the order. So for instance, if it's like 2 times 3 times 10, right? Well, 2 times 3 is 6, and 6 times 10 is 60, right? So my answer is 60. Or if I do it this way, 10 times 2 is 20, times 3 is 60, so it's still 60. Or if I do it this way, 3 times 10 is 30, and 30 times 2 is 60, it's still 60. So I like to use that property here and say, okay, well, what's 1/2 of 25? That's going to give me a decimal, so I don't really want to mess with that right now. So I'm going to say, okay, what's half of the number 8? Okay, half of the number 8 is 4, and then 4 times that 25 is 100. So my area is equal to 100 inches squared. Okay. Now, if you're like, Mr. Essie, I kind of get what you're doing, but I'm a little lost. All right. Well, what's 1/2 of 25? And some of you guys may be hung up on me doing this 1/2 of. Okay. It's because if you do 0.5, if you just chuck in your calculator, 1 divided by 2, right? That's 0.5. So 0.5 times 25 is 12.5. But 1/2 of 25 is also 12.5. So the way I think is going to help you moving forward in math throughout the years is to think of this when you do 1/2 times 25, if you think of it as like half of the number 25, okay? So that would be 12.5, and 12.5 times 8, if you punch that in your calculator, that's going to give you 100, okay? So that's how I'm getting 100. I'm just trying to give you guys a couple tricks that might help you in the future. I like to do the half times the even number, because I know when I do half times an even number, I'm going to come up with another even number. All right, so the area of the trapezoid is 100 inches squared. The area of this rectangle is the base times the height, right? This one's easy, 5 times 7 or 7 times 5. And that's 35 inches squared, okay? So if I know that the area of the whole thing is 100 and the area of that inner part's 35, then to find the area of the shaded part, I'm going to have to take 100, take away the inner part. So my answer would be 65 inches squared. The area of the shaded region is 65 inches squared, okay? So why don't you guys go ahead and try number 4? Okay, so go ahead, pause the video if you didn't. Give number 4 a shot. Let's see what you got. If you did that correct, you should have got 40.5 meters squared. 40.5 meters squared. All right. All right, this one here, I'm also going to have you guys do number 3. Okay, so number 3 you guys do on your own. That's just composite figures created using a square and a triangle. What's the area of the figure? Okay, so on this one, you don't need to subtract anything. You just need to add the area of this one and the area of that one to find the area of the whole thing. So why don't you guys go ahead and try that. The big thing here that I want to get you started on is finding this number. We know if this is 12, then below here, that has to be 12. Because it tells us it's a square. So we know this is also 12, and this is 12. To find this number here, you're going to have to get creative, because if we know from here to here is 21, and we know that that's 12, then what would this be? Okay, what would that be if we know the whole bottom here is 21, and we know that that far is 12? What would that be? All right, so you're doing 3. If you did 3 correct, go ahead, pause it. You should get 198 inches squared if you did 3 correct, 198 inches squared. And finally, on number 2, a patio is being landscaped with trees and shrubs. How many square feet of landscaping will be around the patio? So they're looking for all of this. This, 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 and this. Okay. Now you may have to get creative here. So you got a couple things here. You got, here's a rectangle. So maybe you could find like this rectangle and then subtract out this middle part. And then whatever number you get there, maybe times it by 2, because there's 2 of them. There's one of them here and one of them here, and they look like they're the same dimensions, because this is an 8 and 8. That's a 14 and a 14, and this is a 3 and a 3. So why don't you guys go ahead and try that one? That one's going to be tricky, but I like you to give it a try, see what you can do with that. Subtract out the part you don't need to find the area that's shaded, okay? Go ahead and pause it. And if you did that correct, you should have got 184 feet squared. Okay, so thanks for your effort today, guys. Composite figures, pretty neat, pretty cool seeing things that form together. Composite figures, 2 shapes that form one shape, and you can decompose them, take them apart. So I hope you guys have a great day. Your assignment will be posted for Wednesday, which is all this stuff we did. Thank you.